All right, direct variation is also known as proportional. I don't know if that really helps. But the nice thing about direct variation, proportion, I think I spelled that right. You have a proportional constant, which is also the constant of direct variation. Why do they call it two different things? The same thing, two different things. It's because it makes us math people look smarter than we are. If you can become a math nerd like we are, then you can look smarter than you are too. But until then, you got to work on it, okay? Now, usually we would set up direct variations as a proportion like this one, and it's legitimate to do that. On the other hand, you can find the proportional constant. The proportional constant, if you remember this stuff from back in like 900 or 950, it's also known as a unit rate. If it's a unit rate, then it just has labels, right? Like miles per 1 hour or dollars per ounce. You see what I'm saying? One of the ones is one of the values is a 1, okay? And then if you wanted more, like if you knew that you were paying 25 cents per egg and you wanted to know how much a dozen was cost, you'd multiply 25 cents by 12 and then you'd have the cost of a dozen. I remember when they were like 99 cents. But in any case, the reason why I'm bringing up the proportional constant K is because we're going to need it when we get to joint variation, which it's worse than it sounds. Then K equals Y divided by X. Usually what they'll do is they'll show it as like X equals KY or something like that. Maybe I got those switched. I guess it'd be Y equals KX. Yeah, that seems better. And then you manipulate this equation for K, which is your proportional constant, just to get you prepared. This one says Y varies directly as X. And this wording right here, I hate it. I don't know who wrote it that way, but some math nerds at some point was like, dude, watch this. And they did it, okay? I don't have any control over that. It's just, all we're concerned about here is that it varies directly, and then we know it's a proportion. Now, I'm going to do this two ways, all right? So I am going to set up a proportion, which means you have two fractions that are equal. All right, now with this, it doesn't matter where you put your y's or your x's, even though it says y varies directly as x. Generally, that would mean that you put your y's on the tops and your x's on the bottom, but it doesn't matter, okay? So this first set, it says x is 5. By the way, that should be an ordered pair. Like if you were to graph that, you'd have an x that's 5. I've got my x on the bottom, and when the y is 40. So I've got my y's on the top, okay? Again, if you have that flipped, it's okay as long as your other fraction is flipped as well. The next one, it says find the y. So again, I got my y's on the top when x is 2. So my x is 2, it goes on the bottom. Then you solve this however you like to solve your proportions. Most students in the past are like, Mr. Sal, I'd really like you to use cross multiplication. I prefer fish method, but this is good too. So cross multiplication says you take the 40 and times it by the 2, and that should be exactly the same as 5 times the y. 40 times 2 is 80, and that would equal 5 times y. And then to solve that, y, we would just divide both sides by 5. Just like you would an equation, right? So that's a phantom 1y equals 18? Thank you. Math is hard. So use calculators. Please don't do that in your head like I did. And can we check this? Well, yeah. Just take your y there and replace it with 16. 40 divided by 5, by the way, you would have gotten, if you had done that division, you would have gotten 8. But 16 divided by 2, also 8. Now we know the equal sign is true. And we found the appropriate and correct value of y that makes it true. So we found the solution, and we can feel good about boxing that in. So that's one way to do it. The other way is to use well, I guess it'd be the proportional constant. This one, you can also solve for the proportional constant. So remember, k is the same as, it says y varies directly as x, so that should be y over x, I guess. And then the first value says y was 40, and then the x was 5, so your constant, your proportional constant here is 8, which I guess what we got right there. And so or y equals kx from that last slide. So we're solving for y in this case. The k is 8, the x is 2 for that one. It's the green 2, which is 16. So you get the same answer both ways, but this one is using the proportional constant there in red. And again, the reason I bring that up, I never do it this way. I mean, you're welcome to do it, but I generally solve my proportions this way, but this is all in preparation for what we're going to see as joint variation. If something varies directly as x, the k is equal to y over x. Really, this is the formula that you'd want to look at, that y equals kx. Y varies directly as x. Now, if that was x varies directly as y, then it'd be x equals ky, but whatever.